Hello everyone. Hope that all of you will be safe in this COVID pandemic. Today's virtual talk has been put on the raw water and its treatment. We will talk it well, understand it. I came to know that a lot of students are come from Bihar in this session, which is associated with the engineering colleges and polytechnic colleges. Uh, so I will humbly requested all of you to listen to this session carefully. This will be benefit you in the semester along with the importance of water in your life. So all of you listen to my words and support me. Before I start the presentation, I request you all to put your volume mute so that there is no any disturbance during the session. So I will start now. The very basic thing about raw water, its treatment, we are going to discuss. So here is our content part, in which we are talking about our introduction part, the source of water, water demand, quality of water, and treatment of water. The question is that how exactly the one treatment plant take dirty water or well water or river water turn into the water that is safe to drink. So it involves a lot of process using chemicals, filters, and sedimentation that removes all the toxics from the water. We are here know about the entire process. First of all, we are talking about water. So water, the basic thing we say about water is the water is life. Because why we can discuss here, water is one of the basic needs of life and essential for survival. Water carries nutrients to all cells in our body and absorb to our brain. Water allows the body to absorb and assimilate minerals, vitamins, amino acids, glucose, and other substances. Water flushes out toxins and waste, and it helps to regulate the body temperature. So we see that the entire process we will be carried in our body, which is the main role carried out by the water. In India, groundwater is used as a raw water for 85% public water supply. Here is some fact we are going to discuss. That the water covers 71% of the Earth's surface and 326 million cubic miles of water on the planet. 97% of the water is found in ocean that is too salty for drinking, growing crops, and most industrial uses except coolings. Almost 320 million cubic miles of water in the oceans. 3% of the Earth's water is fresh and 2.5% of fresh water is unavailable. That is, they are locked up in glaciers, polar ice caps, atmosphere, and soils, or lies too far under the Earth's surface to be extracted at an affordable cost. 0.5% of the Earth's water is available as fresh water. If the world's water supply were only 100 liter, that means 26 gallons, our usable water supply of fresh water would be only 0.003 liter. That is one half teaspoon. So in actually the amount of to an average of 8.4 million liter, that means 2.2 million gallons for each persons on earth. So now we are going to talk about what is the factor that affect our water demand. So first of all, we are talking about the size of city, because size of city is directly proportional to water demand. If a city having a large population, then obviously there is a large demand, and if a city has a small population, then obviously there is low demand. So if we are talking about the demand, I think here is some slides are. Yeah, obviously we have source of water. First of all, sorry, For that, here we are talking about the source of water. So in ocean, there are 97.2% of the water in our oceans. Then ice caps, 2% water in ice caps, which are locked. Then groundwater, which is 0.62%, fresh water lakes 0.009%, or inland sea or salt lakes, that is 0.008%, and atmosphere, that is 0.001%, and river 0.0001%. So this is the source of water which are varying from this part to that part. So overall variation of the water which are shown clearly here. And now the water demand. So first of all, we are talking about raw water. So raw water, any sample of water which is being utilized from the natural source, such as lakes, river, ponds, well, uh, and it is not being subjected to any artificial treatment. So here is some types of demand, such as domestic water demand, industrial water demand, water for public use, fire demand, losses, and theft. So first we talk about the domestic water demand. It is the amount of water required to satisfy the domestic needs, like drinking, cooking, washing, bathing, etc. For a city having full flushing system, it is in the range of 135 to 245 LPCD. That means liter per capita per day. Uh, if we talk about the industrial water demand, it is the amount of water required to satisfy the industrial needs. Depending upon the extent of industrialization, it is in the range of 50 to 450 liter per capita per day. Another one which are not here shown, but institutional water demand. It is the amount of water required to satisfy the needs of the different types of institutions in our community, like schools, hospitals, railway stations, airport, etc. And it is in the range of 20 to 50 LPCD. The next one is water for public use. So it is the amount of water required for public utility purpose, like washing of road, gardening, etc. It is taken as 5 to 6% of the total demand of water. Generally, it is vary between 10 to 20 liter per capita. And the last is the fire demand. It is the amount of water required in case of fire breaks out. It is taken to be 1 LPCD, or can also be found empirically by some formula which is given by our government of India manual method, which is almost equal to 100 under root P, where population P is population, which is in 1000. Another one formula is given by National Board of Fire method, which is given as 4637 under root P, 1 minus 0.01 under root P, where population is also in 1000. This all water gives in liter per minute. And the last is losses and theft. It is the amount of water which is being wasted out due to leakage and theft in a raw water scheme. So it's maybe extended up to 10 to 15% of the total demand of water. So our next slide is about now factor affecting demand. So here is the first of one is size of city, climatic condition, type of sewage system, extent of industrialization, cost of water, quality of water, type of distribution system, and pressure in distribution. So these all things affect our water demand. I think most of them is directly proportional to demand. The size of city, it is directly proportional to water demand, because if the city has a large population, that is directly affect the demand. And if a large population, then the demand will be high. If a small city, then demand will be low. Climatic condition, if the climate is hotter condition, then the demand will be affected, demand will be high. Type of sewerage system, if a proper facility of sewerage system, then also demand will be high, because you have a proper facility of the sewerage. Extent of relation, how much industry have in the city. If there is a large city, then it's also affect our demand. Demand will be high in that area. cost of water. Have you put the cost on water? If you put cost on water, then demand will be low. If there is no any cost for water, then demand will high. Quality of water. If you put a quality of water, then also demand will be high. If the water is not quality, then demand affected and demand will be low. Type of distribution system. Uh, how much pipe have you distributed in that area? Uh, so it's also affected if the number of distribution pipe are available there and a proper distribution facility is available there, then it's also affect our demand. Demand will be directly proportional to it. And the last is pressure. It's also is directly proportional because if the pressure is high, then demand, then uses of water will be high, or losses of water will be high. It's all almost except the cost of water is directly proportional to water demand. So our next slide is about quality of water. So quality of water, we are talking about the quality of water, but here is a three form of to check the quality of water. First is physical parameter, second one is physical parameter, and third one parameter. If we talk about physical parameter, there are various things we are going to discuss. First one is suspended solids. Second one is turbidity. Third is color. Fourth is temperature. And the last is just and order. So if we talk about the suspended solid, because I think the quality of water is found with the help of certain indicator and parameter known as water quality parameter. So is all are classified as physical, chemical, or biological. So we are going to physical, and in physical we are going to suspended solids. So suspended solids may come from organic matters such like algae, plankton, or may come, also from inorganic matter such as sand, silt, glass, etc. So you have to note that the organic matter may either be biodegradable or non-biodegradable, and biodegradable organic matter can be decomposed by the action of microorganisms. Now we are talking about the turbidity. Turbidity is extent to which the light is either scattered or absorbed by the presence of suspended particle in water. So if a water is more turbid, that means there is more suspended particle in water. So there is less a light is scattered. So we have a instrument, a turbidity rod meter, which is used for this to measure the turbidity. There is also various methods to measure the turbidity, just like Jackson turbidity meter, Bailey's turbidity meter, nephelometer, and this all have a process. But overall, we have to remember that the Bailey's turbidity meter is based on absorption principle, and nephelometer is based on scattering principle. So permissible limit of turbidity is 1 NTU, and cause for rejection is 5 NTU. So now we are talking about color. Color is due to suspended solid. There are several color causing compound like iron, manganese, which are increase the demand of chlorine in water. There are several colors compound like phenol, which are reacts with chlorine to give taste and odor in water. So it is measured by the color matching technique in device term as tintometer. So with tintometer, acceptable limit is 5 true color unit, and cause for rejection is 50 true color unit. Next one is temperature. Temperature of water affects both rate of chemicals and biological reaction. An average increase of 10 degrees Celsius in temperature of water almost doubles the biological activity. So the water supply's temperature must be in the range of 10 to 25 degrees Celsius. The last one is test and order. Test and order in water is induced by the inorganic minerals, salts, organic matter, and dissolved gases like carbon dioxide and hydrogen sulfide. Test and orders in water result in the formation of carcinogens, which is cancer causing substances. So it is done by device osmoscope, and the limit is one order number, and the phosphor rejection is 3 TON. So next slide is going for chemical parameter. In chemical parameter, we first of all talk about dissolved solids. Dissolved solids in water can also be termed as approximately by measuring the electrical conductivity of water. So it is almost electrical conductivity into 0.65. That's the total for gram per liter. Second one is alkalinity. It is the ability of water to neutralize the acid or maybe defined concentration on in water, which are capable of neutralizing hydrogen ion. So major cause of alkalinity is OH minus, that is known as caustic alkalinity, HCO3 minus, bicarbonate alkalinity, CO3 2 minus, carbonate alkalinity, and the minor sources HS minus, ammonia, H2PO4 minus, HPO4 2 minus, H2PO4 minus, and so on. The sources of alkalinity in water induced by the inorganic minerals, salts, organic matter, and dissolved gases like carbon dioxide, ammonia, or hydrogen sulfide. So uh, next was about pH. So pH is generally measured by a artificial scale in the range of 2 to 40, which is used to indicate the acidity or basicity of the water. pH of water can be found either with help of a color indicator like saline, lorraine, or which work in the range of I think 6 to 7.6 approximate, and the apparatus used is termed as aquascope or by potentiometer. So acceptable limit is almost 6.5 to 8.5 almost. So our next is hardness. Yeah, it is defined as the quality of the water to destroying the surfactant property of soap. That means the property of soap by virtue of it is able to form leather with water. It may also be defined as all the multivalent cation present in the water. So here we are another major and minor wala concept. So CaSO3 whole twice, CaCl2, CaSO4, CnO3 whole twice. These all are in the minor concept. So major cause of the hardness is calcium and magnesium and the multivalent cation. But the in minor Fe2 plus, Mn2 plus, Sr2 plus, Al3 plus, Cu2 plus, Pb2 plus. These are minor, but the calcium and magnesium are in major concept. So hardness of water is further classified as carbonate hardness and non-carbonate hardness. So hardness due to carbonate or bicarbonate, Cu32 minus, Cu3 minus of multivalent cation is termed as carbonate hardness, and hardness due to Cl minus, SO42 minus, NO3 minus is termed as non-carbonate hardness. Carbonate hardness of the water is also referred as temporary hardness. So it is easily removed either by boiling or by addition of lime, whereas non-carbonate hardness is termed as permanent hardness. So we have next one is chloride content. Presence of chloride in water indicates its pollution either due to sewage or industrial waste. Excess of chloride in water imparts bad taste affect our heart, skin, and also blood pressure because thereby cause hypertension. Chloride in water is determined by the titrating it with silver nitrate AgNO3 solution using potassium chromate K2CrO4 as an indicator. So acceptable limit of chloride is 250 milligram per liter, and the cause for rejection is 1000 milligram per liter. Next one is fluoride content. Fluoride up to 1 milligram per liter is required to be otherwise it helps in preventing dental cavities and for the growth of permanent. Fluoride in concentration more than 1.5 milligram per liter causes molting of and decoloration of the teeth and result in disease term as fluorosis. So another one, if a fluoride is greater than 5 milligram per liter, it carries out chemical deformation of the bones because of the presence of calcium phosphate in it and result in the disease term as the bone fluorosis. So fluoride in water is determined by color matching technique uh, where we added germanium ion and check it. So acceptable limit is 1 to 1.5 milligram per liter. Now, and the last one is nitrogen content. The presence of nitrogen indicates pollution due to organic matter. Nitrogen in water may be found in any of the following forms, such as free ammonia. Free ammonia in water indicates is pollution, and it is determined by water sample. Its acceptable limit 0.5 milliliter. Second is organic or nitrogen before pollution of any matter start. It is by all wild sample of water which the addition of alkaline reagent like potassium, also known as lava, and nothing the amount of ammonium gas liberated. Stable limit organic ammonia 0.3 milligram per liter. And you have to note that the free ammonia and organic ammonia taken together is termed as Zeldal ammonia. Third one is nitrites, NO3 minus. So presence of nitrite water really as gets the partial decomposition of organic matter. That means the microorganism will be present. So it's acceptable 0 per liter, not permitted slightly. And the last one is nitrate. Pressure of nitrate in our water is not harmful. So as it indicates the complete decomposition of organic matter. So if its permissible limit is 45 milligram per liter, but if presence is greater than 45 milligram per liter, that affect the infants the term as methylglobemia, that is also known as blue baby disease. It is also determined by color matching technique where color is induced by addition of phenol disulfide potassium oxide. So this all is a chemical parameter. Now we are talking about the biological parameter. In biological parameter, the first one is membrane filter technique. Second one is most probable number method, and third one is coliform index test. So testing of coliform is done by any method. Membrane technique where a member is to member 5 to 10 meter to 35 meters for 20 hours, and then the colony of a coliform will be formed. In most probable number method, it is the multiple tube fermentation test in which water samples of different dilution ratio are mixed with the lactose food. That means a food of coliforms, and it is incubated for 48 hours. There are three samples, 10 ml, 1 ml, and 0.1 ml, are tested for the presence of coliform by the testing of presence of acid and alcohols in these samples. And the result of the coliform obtained in the further calibrated with the dose of pathogens present in the water. So, and the last is the coliform index test. In real terms, it is not a matter of testing of coliform in water. It is used to represent the coliform in terms of the parameter like coliform index, which is defined as the reciprocal of a smallest quantity of the sample that shown the presence of the coliform in it. So this is the our biological water quality parameter, and here is the we are standards. What are the standards for drinking water? What are the permissible limit for any of this parameter? So we can clearly say that there is in physical color is in given by our three standard where first one is ISI international standards, second one is ICMR, and third is WHO. So the gives the total permissible limit about that and the excessive limit. So if color we talk about 10 to 50, they are all in between this range. But the ICMR is for about it's 5. India has also a lot of standards, just like ICMR, Bureau of Indian Standards. According to what as for Bureau of Indian Specification, there's a specific code, IS 10500, which is in publication 2002. Uh, so overall, they are came in effect with the objective so to access the quality of water resource and to check the effectiveness of water treatment and supply by the concerned authority. So we have also always keep in our mind that our drinking water not crosses this permissible limit. So now here we are talking about the treatment of water. So treatment of water is done with the screening, then aeration, coagulation, flocculation, sedimentation, filtration, disinfection, and last is softening. So first we talk about screening. In the process of removal of heavy solids from water like plants, trees, animal, stones, etc. We are doing screens. It is done generally for the treatment of surface water because groundwater does not contain large particles. Screening is done with the help of the units termed as screens, which are broadly classified into two parts. First one is coarse screens, and the second one is fine screens. So if we are talking about coarse screens, uh, these screens are in form of bars of dia 10 to 25 mm, having a spacing of 20 to 100 mm, center to center in between them. These screens are always placed at an inclination of 3 to 6 vertical to 1 horizontal, as it helps in effective cleaning of the screens by rocking mechanism. So here will be head loss occurs. So we are trying to be put the screens at an inclination. Second one is fine screens. These screens are in form of wire mesh of size less than 10 mm under normal treatment condition. Fine screens are avoided as they get chalked frequently, uh, requiring frequent cleaning, which in turn increase their operation cost. Hence, it is recommended to use coarse screens instead of fine screens and to remove the fine suspended particles in following sedimentation and filtration process. Second one is aeration. It is the process in which water is brought in intimate contact with air so as to allow the absorption of oxygen in it which uh, required for the removal of the following dissolved impurities from the water: dissolved gases like carbon dioxide, hydrogen sulfide, dissolved organic matter, volatile liquid like phenol, humic acids, dissolved minerals like iron, manganese, It is adopted generally for the treatment of water which is dissolved oxygen, example groundwater or water at the bottom of the lakes. So there are various method for the aeration, that is spray nozzle method, tray tower method, gasifier aeration method, diffused air method. These all are method. Now we are talking about the sedimentation, and if the proper sedimentation will be not occurred here, then we would chemicals such as coagulation, and the process coagulation will be occur, and then after the sedimentation will occur. So sedimentation, it is a process of removal of the suspended particles from the water. The entire theory of sedimentation is based upon a single parameter, is known as specific gravity. During sedimentation, all the factor which opposes the tendency of settlement of the taken place are velocity of flow, that means turbulence, viscosity, and size of particles. So this is the sedimentation part, and now we are talking about coagulation part. So coagulation, it is the process in which certain chemicals termed as coagulant are added in water so as to coagulation. In this process in which certain chemicals termed as coagulant uh, are added in water so as to neutralize the negative protective charges present over the suspended particles and to form a sticky precipitate which attracts fine suspended particles over its surface, loading to formation of a bigger size particle which can get easily settled in the following sedimentation process. In order to neutralize the charge over the suspended particles, certain minimum energy term as threshold energy is required to be provided, which induced by fast mixing in this process. There are different chemicals used as a coagulant, such as alum. Alum, that means Al2SO4 whole thrice and 18S2O. And this is a hydrated aluminum sulfate, which added with water reacts with its alkalinity present in it, and leads to the formation of a sticky gelatinous precipitate of aluminum hydroxide, which attracts fine suspended particles over its surface, leading to the settle in the following sedimentation process. If alkalinity is not present naturally, it is induced artificially either by the use of lime or soda ash. So another one is copras. So copras is FeSO4 7H2O hydrated ferrous sulfate. It also reacts with alkalinity present in water used to uh, uh, formation of sticky precipitate uh, of ferrous hydroxide, which attracts fine suspended particles over its surface and leads to the formation of a bigger size particles which can get easily settled in following sedimentation process. Its normal dose is 10 to 13 milligram per liter. Third one is sodium aluminate Na2Al2O4. It reacts with calcium or magnesium present in the water and leads to the formation of calcium, magnesium, aluminum, which attracts fine particles over its surface and leads to the formation of bigger size particles which can get easily settled in the following sedimentation process. Its normal dose is 10 to 30 milligram per liter. And the last one is chlorinated copras, which is plus FeCl3. It is formed by the addition of chlorine in copras. If FeCl3 is used independently as a coagulant, it works in the pH range of 3.5 to 6.5 and above 8.5. So after coagulation, we are talking about the flocculation. So it is the process in which neutralized particles are brought in intimate contact with each other and with a sticky precipitate, resulting in the formation of bigger size particles which can get easily settled in the following sedimentation process. In order to increase the tendency of combined slow mixing is also induced in this process. We are See here that during flocculation, a parameter G into T represent the coagulation opportunity at is signifies the number of collision between the particles. Thereby, it helps in identifying the type of flux formed. Coagulation opportunity GT is always constant. If G is increasing and T is decreasing, then the flux form is dense and small. If G is decreasing and T is increasing, then there will be a light and large flux. So as dense and large flux form, um, because it easily settle in sedimentation tanks, hence the value of G at the inlet of the tank is kept to be twice the value of G at the outlet of tank. So generally the detention time will be 10 to 30 minutes and the temporal mean velocity is equal to 10 to 75 per second. So now we are talking about the filtration. It is the process of removal of fine suspended particles and flux that could not be removed in sedimentation. Filtration, apart the removal of suspended particles, also removes organic matter, microorganisms, and dissolved solids from the water. Generally, there are two ways for filtration. First one is gravity filters, where we have two options: slow sand filter, rapid sand filter. Those in which the head required by the water to overcome the resistance is obtained by the water from its own height or weight above the medium surface. So we have used a slow sand filter and rapid sand filter. And the second one is pressure filter. They have energy required, and the treatment is carried out in a closed container. Another one example of pressure filter is reverse osmosis process. RO filter is used as a based on the principle of pressure filters. So we are talking about the reverse osmosis. So RO purification is the most advanced technology that is for the process that uses it from uh, under the process, the molecules are forced to pass to semi-permeable membrane in order to less solution. Since the pore size of 0.005 might be to pass, the purification process is capable of removing any kind of impurities, starting from dissolved solids, salts to bacteria, virus, and heavy metals. If filtration can improve the odor, appearance, and a small taste of your water, as to right as it fit the order overall our the advantage of the major disadvantage of our system is that remove most of the water. Uh, Water obtained from RO filtration process has a low pH value. So prolonged consumption of a low pH water has adverse health effect such as increasing the risk of kidney disorder and gastrointestinal troubles. In India, ministry was acting on a national green tribunal order. The order asked to prohibit the use of RO purifier where TDS in water are below 500 milligram per liter. So this is our RO process. Now we are talking about Our next slide. So here we are talking about softening of water. So it is the process of removal of hardness from the water. It can be done by following two methods generally, lime soda process and zeolite method. And the last one is demineralization. So lime soda process removes all the carbonate hardness present in the water, where lime converts non-carbonate hardness to magnesium into non-carbonate hardness Ca2 plus, and lime also reacts with the carbon dioxide to get wasted out as a calcium carbonate. Where carbonation, recarbonation, these all parts will be occur. So we are talking about if zeolite method. It is a natural or synthetic cation or base exchange hydrated silicates of aluminum and sodium. Zeolite. If equipment used in this case same as the pressure filter, uh, when hard water is passed through the zeolite bed, and it exchanges its univalent sodium ion with the multivalent cation, causing the hardness in the water. But get itself exhausted, which is further regenerated by the passing 5 to 10%. This method gives zero hardness, zeolite method, water, and does not lead to the formation of sludge while removing the hardness. Demineralization is the process of removal of minerals from the water, in which a treatment is being carried out in two stages, where in the first stage of the treatment, water is passed through the cation exchange resin and that removes the hardness of the water, but induced acidity in it, which is further removed by passing it acidic water through an anion exchange resin. Exhaust cation exchange resins in regeneration by passing acid solution through it. An exhausted anion exchange resin is regenerated by passing alkaline solution of the soda ash through it. This method also gives zero hardness water and does not lead to the formation of sludge. So now we are talking about disinfection. It is the process of removal of disease-causing microorganism, that is pathogens from the water. The process of removal of all type of microorganisms from the water is termed as sterilization. It is the minimum essential treatment required to be given to the water and being adopted at the final stage in the chain of water filtration. So during the war time, we directly take raw water or surface water and disinfect it and use it. So it is the minimum essential treatment for water. So disinfection process, we are talking about we can see here the ozonation process and UV filtration process. These are doing in our industrial system. So what is the disinfection process? The minor method of disinfection is treatment with ozone. So O3, when added in water, dissociated with oxygen and nascent oxygen, which carries out the removal of the microorganism and oxidation of organic matter. So nascent oxygen, being highly reactive, strikes with the cell walls of microorganism, thereby leads to its destruction and finally leads to killing of microorganism. Nascent oxygen, being highly reactive, is not capable of safeguarding the water against future recontamination. So ozone has also give pleasant taste in water when used as disinfectant, but is comparatively costlier than other method. Treatment with potassium permanganate. Potassium permanganate KMNO4 is a very popular disinfectant used for the treating well water supply and contaminated to lesser system. We also heard it like as a lal dawa, which are generally used in our well system before 10 to 20 years ago. KMNO4 gives pink color to the water, which is disappears indicates the presence of organic matter and microorganism in water. Hence, it is added in water up to an extent pink color stands in water, indicating as a removal of organic matter, microorganism from the water. So KMNO4 increases the permeability of the cell walls of microorganism in order to carry out the disinfection. So normally dose is 1 to 2 milligram per liter and the contact period is 4 to 6 hours. So now we are talking about the measure of method of disinfection treatment with chlorine. When chlorine added in water reacts with it with at a pH less than is greater than 5, leading to the formation of a highly unstable hypochlorous acid, which further dissociated with hypochlorite and at pH is greater than 7. There's various form of chlorine you use as a disinfectant. Such as free chlorine, chloramine, chloride dioxide, hypochlorite, and bleaching powder. So these all things are discussed here. Now, save water and save life. Save water, save life. This is our last slide. To close this session, I give this line: "Save water, save life," because water is life for human beings as well as for our ecosystem also. So saving water is important for us and for our future generation also. We are dependent on water for many purposes such as cooking, cleaning, bathing, washing, drinking, for toilet purchase, uh, for agriculture, for industry like chemical industry, fertilizer, textile, paper, food, mining industry. We have also used as a generation of power. What is a boon for us, which granted by God, Ishwar Allah. So we should use the water properly. In some areas where the shortage of water will occur, they know the value of it. So water is precious for us. So I request you to all of you to save water and save life. That's all from my side. Over to you, sir.
Thank you, sir. Thank you very much. I hope all participant has get benefited from this lecture. Thank you, sir.